Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can use properties of logarithms in order to condense logarithmic expressions. So what that means is we're going to see multiple parts of logarithms that we're going to condense together and write hopefully as one or two logarithms. Now, these are the properties we're going to be applying here: the product property, the quotient property, the power property, and the fact that the log of any base evaluated at 1 is 0, and the log of any base evaluated at the base itself will be 1. So we're just going to address these with these 5 properties, but you can also condense logarithms using any other logarithmic property. So we are going to take a look at some of these things here. Now, in order to condense logarithms, the most important thing that you notice with all of our properties here is that in every case where we have a product, a quotient, or a power, notice how with those products and quotients, our bases have to be exactly the same. So they all have to be logs. They all have to be natural logs. They all have to be a log of base 10 or a log of base 2 or a log of base pi. It doesn't matter as long as the bases are the same. So what we're going to do here is take a look at how we can condense these. So first we want to check, do they have the same base? And if they don't have the same base, then we cannot combine things together. So in this case where we see log, 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 we know those all have the same base, because when a logarithmic function is written without its base, then it's defaulting to a base of 10. So we have 4 pieces here, all with a base of 10. The next thing that we want to do after we find that same base is we want to do that reverse of the power property. And so what that reverse of the power property says is basically it's going the other way. So instead of having a power that I bring to the front, if there's a number up front, I'm going to rewrite it as a power. So in this case, we have one of those. And I'm going to rewrite our entire expression here. But this piece here is the one that can be rewritten using that power property. So now it's actually going to be a log to the power, log base 10 to the times x to the power of 3. Oof, stumbling over my words. So now we've got a log of 4 plus a log of x to the third minus a log of 2 minus a log of y. Now, after we have that, our third step is we want to do that reverse of our product and our quotient properties. And so as we're doing the reverse of those two properties there, what that means is we're actually going to do them just from left to right. Now, if there is a positive sign in front of it, so it's a plus a logarithm or it's just a positive logarithm, then that value is going to go on the top of our quotient and it's going to be multiplied by any other positive or any other plus. If there is a negative coming in front or a minus sign, so in this example where we have that minus log of 2 and that minus log of y, those are actually going to go in the denominator or the bottom of our quotient, and they're going to be multiplied together down there. And the reason why is because I could group my minuses together like this and factor out a -1, and we end up getting a minus a log of 2 plus a log of y. And that all of a sudden turns those into a quotient. So that's kind of how that idea works there. I'm not going to do it that way for the sake of the fact that we don't always have the option to do that. And so what we're going to do is use that idea or apply this concept of just going from left to right, where if it's a positive log, it goes on top of the quotient. If it's a negative log, it goes on the bottom in order to write this. So in this case, we've got the log of 4, which is positive, so that's going to be on top, plus the log of x to the third. So that means we're going to do that opposite of the product property, and that's going to go on top. We have a minus log of 2, so that means it's going to be that quotient property going on the bottom, and then a minus a log of y, and that's also going to be a quotient problem going on the bottom. But as we discussed before, when we have 2 minuses together, we could imagine ourselves factoring out that negative, and those actually get multiplied together on the bottom. So really, when we go to condense this, log of 4 plus 3 log of x minus log of 2 minus log of y actually just condenses down into the log of 4x to the third over 2y. Now, I personally think that the log of 4x to the third over 2y can sometimes be seen as simpler, sometimes be seen as more complicated. So we want to be able to know how to write either in the expanded form or to go from expanded to condensed, depending on what we're doing. So let's take a look at a couple more examples where we go through these steps the same way. So this next one, we've got all natural logs, so our bases are the same. So step 1, check. Step 2, we want to check for any powers, and right here, we see that power. Now, only our 2 is going to go into the power. That minus sign is going to stay the same. So we now have the natural log of 4 minus the natural log of 3 plus the natural log of x minus the natural log of y squared. Now, as we established before, if there's a minus sign in front, it's going to go to the bottom of our quotient. If there's a plus sign, it's going to go to the top. If they're all positive, then we know that this is only going to be a product property, but that doesn't often happen. So in this case, now we're doing that third step where we go through and we are doing all of our products here. So I've got the natural log. That's where we're going to start of positive. This piece here is positive, so it's going to go on top. This piece here is negative, so it's going to go on bottom. This piece here is positive, so it's going to go on top. And remember, when they go on top, if there's more than one, we're going to multiply those. That's how that product property works. And this one is going to go on bottom because it's a negative. And so ultimately, this ends up being the natural log of 4x over 3y squared as we move those there. Okay, we're going to take a look at two more examples. These ones have been pretty basic here. Looking at this next one, again, just like we did before, we want to check, do we have the same base? And in this case, they're all a base of 3, so that works. So that's step 1 of the base check. We are good to go here. Our step 2 is to check for any powers. Now, in this case, we do have a power in that first piece here, so we're going to rewrite it that way. So I've got log base 3 of x squared plus log base 3 of y minus log base 3 of xy. Now this xy could have been expanded one more time as a product property, but it was not. And we do not want to expand it because we are trying to condense here. And then our third step is to do that quotient and our product rule or product property. And so with those, remember, if it's a positive sign in front, it goes on top. If it's a negative sign, on bottom. And then we'll go from there. So in this case, we've got the log of base 3 times, well, our x squared is positive, so this is going to be on top. This term here is positive, so it's going to be on top. This term here is negative, so it's going to be on bottom. Now you may be noticing here that we've got an x squared and a y on top and an x and y on bottom. So how does this relate? Well, when it comes to condensing, you haven't seen it with the other ones because they've kind of stopped there. We've only had x's and y's. We've only had x's and y's. But with this one here, we actually had a 4th step that we can include. And we're going to do it with that other problem as well. So in that very first example, our 4th step is actually going to be to simplify. So when it comes to simplifying, what that means is if there's anything I can simplify or cancel out here with this function, I'm going to do that. So in this case, where there's a 4 and a 2, this actually simplifies. So this is not my final answer, but I can actually write this as the log of, well, 4 divided by 2 is 2, 2x to the 3rd over y. And that's even simpler than 4x to the 3rd times 2y. This previous problem that we did, it's as simplified as it goes, but this one, we can actually do that simplifying step one more time after we have combined it. So now that we've combined it, let's simplify. Well, I've got 2 x's on top and 1 on bottom, so I can get rid of one of those x's because this is x times y over x times y. So I can cancel out these x's, I can cancel out these y's. So this expression here is actually just going to be log base 3 of x because that's all that's left here. And let me tell you, 2 log base 3 of x plus log base 3 of y minus log base 3 of xy, that is way more complicated than just telling someone log base 3 of x. And that's ultimately the reason why we want to condense, is to see how simple can I write it. And sometimes by expanding and then condensing what we've expanded, we can get something significantly simpler. So let's look at one last example here of us condensing these logarithms using our properties. Now we're going to go through those same things again that we did before. So we want to check our base. Does this have the same base? In this case, everything does. Our second step is to check our power. Now in this case where we have a 2 on the outside, what I'm going to do is I'm actually going to distribute that first in order to figure out what my power is here. So if I distribute that, I really have a 2 times the log of 2x plus 2 times the log of 3y. Now we're going to do that power rule, or that power property, meaning that my exponent's going to come to the top of both of these. Now, because we have a product inside, we have that 2 and that x, we have that 3 and that y, our exponent is going to go on the outside of both of them, which is why I wrote 2x and 3y in parentheses here. So this is really the same as log of 2x squared plus the log of 3y squared. And now we've taken care of our powers. Our third step here is to do our product and our quotient. And so we are going to combine those. Because these are both positive, it actually just turns into a bigger quotient here. So we've got the log of 2x squared times 3y squared. And we've checked that. And then our last step here that we established is to simplify. Now, as we're looking at that simplifying, is there anything here that can simplify? In this case, there is not. So we are going to leave our answer here at 2x squared, 3y squared. If you have any questions, don't hesitate to reach out, but this is how we can use those 5 properties of logarithms that we've discussed, or really any properties, in order to condense and expand it out logarithmic expression.